dinosaurs make their appearance in the mid-Triassic, about 233 million years ago, with Saurischian dinosaurs. Like the Theropsids, the first dinosaurs had faster metabolisms than their archosaur relatives, and independently solved the problems of having a sprawling leg position like lizards by becoming bipedal. Subsequently, they independently evolved very large dinosaurs at least 6 times, producing huge quadrupeds 4 times, and giant bipeds at least twice. Dinosaurs probably all had parental care and vocalizations, since these are present in crocodilians, pterosaurs, and birds that represent both ancestral groups and derived groups to dinosaurs. For instance, crocodiles build elaborate nests of decaying vegetation, they vocalize with their young, they protect nests, and they care for hatchlings. All features found in birds, and probably all the main groups of dinosaurs as well. Now, I have personal experience with this, since we had 2 American alligators when I was growing up that lived in a fish pond in our backyard. They would bury eggs in our compost pile, defend it by hissing, and then call to their babies when they hatched to get them to dig their way out of the nest. The parents would then carry the hatchlings in their mouths back to the fish pond that was their main home. Similar communal nests have been documented in dinosaurs, of course, but most reconstructions are very unrealistic and show the hatchling dinosaurs in wading pool-like nests, rather than in the much more probable large piles of rotting vegetation. Rotting vegetation is also used as a nesting strategy by very derived dinosaurs, like living bush turkeys in Australia, suggesting that this nesting approach was widespread in all the dinosaurs as well. For very large dinosaurs, weight was an issue. All the Saurischians have air sacs in the neck and the lower back that increase the oxygen carrying capacity of the animal during activity, and therefore the physiological rate relative to similar-sized mammals. The air sacs also help to lower the weight of the bones in the neck and the tail. Even so, big sauropods had to heavily mineralize their legs and parts of their vertebra, accounting for the generally excellent preservation of these skeletal elements. Indeed, there is a pervasive bias in dinosaur paleontology towards the discovery of limb bones and away from finding skulls. Hence, many dinosaurs are known mostly from non-cranial bones. In the Triassic and Jurassic, most terrestrial plants were relatively indigestible gymnosperms, such as conifers and cycads. Studies have shown that conifers have broadly similar nutritional value compared to other plants, but the overall level of plant defense is very high in gymnosperms. The bark, leaves, roots, and cones are all infused with nasty chemicals like terpenes, and heavily constructed of woody material like cones. Angiosperms, in contrast, put on leaves that are more disposable, and so tend to be less defended than those of conifers. Angiosperms also produce fruits, as well as inner bark and roots that make decent forage. For instance, I've watched elephants push over trees to eat part of the root crown. This strategy often does not kill the tree, but instead produces clumps of resprouts off the down trunk, creating a bushy landscape. Now, like modern birds, herbivorous dinosaurs used a muscular gizzard containing gravel to grind up food and mix it with bacteria for digestion. The gizzard is combined either with a very small head for collecting vegetation with minimal processing, or a tooth battery for shearing up plant material before it is sent to the gizzard. Some dinosaurs also used a stomach digester approach, a massive barrel-shaped gut for bacterial decomposition of plant material. This massive gut is also an explanation for the bird hip structure of some Ornithischian dinosaurs, who needed the pelvic bones to support their stomach digester. Others, like duckbills, may have consumed plant parts with higher food value and did not need that barrel-shaped gut to process low-nutrient plant parts. Duckbills, as it turns out, diversified in the late Cretaceous with the angiosperms and consumed food with higher food values such as leaves and fruits. The angiosperms are probably behind the major radiation of the armored dinosaurs and the duckbills that starts about 75 to 85 million years ago. Now, there are 2 main clades of dinosaurs, the Ornithischians, the armored, horned, and duck-billed dinosaurs, and the Saurischians, the theropods, birds, and sauropods. The Ornithischians are united by possessing a fleshy cheek for manipulating food. Many of them also had leaf-shaped teeth for slicing vegetation, wide rib cages to support a large hindgut for fermentative reduction of low-nutrient plant material, and a tendency to feed low to the ground. Examples include the armored dinosaurs who radiated mostly in the late Cretaceous, along with the flowering plants. Other ornithischians include the Ceratopsians and hadrosaurs that both have tooth batteries with blade-like cutting surfaces, and the ability to shed their teeth like a shark when they wear out. These animals move the jaws from side to side as well as up and down to macerate food before delivering it to the gut. Most were at least partly quadrupedal, with hooves on the forefeet, even ornithischians like duckbills. The hooves are not just for walking. For instance, Iguanodon had forelimbs specialized with an opposable pinky, 3 hooves, and 1 stripping claw. This morphology was probably useful for stripping leaves off of tough stems to avoid eating a lot of woody plant parts, and to avoid plant defenses like thorns. Herding is a common strategy amongst ornithischians, as shown by both monospecific bone beds and by trackways. As proper herding animals, features like the head frill in ceratopsians and crest bones in duckbills are regarded as tools for sexual display and mate competition. Both frills and crest morphologies probably become more elaborate in more derived forms, suggesting the evolution of sexual selection reminiscent of the display features in pterosaurs. Now, the second large group of dinosaurs are the Saurischans, which include two large subgroups, the Sauropodamorpha and the Theropods. The Sauropodamorpha include the true giants. All are derived forms with quadrupedal and ligament-supported necks, up to 8.5 meters long, and a long counterbalancing tail. Big animals were upwards of 130 feet long. It's hard to imagine that, and maybe 70 to 100 tons. The numbers are hard to imagine, but for comparison, an elephant is perhaps 10 tons. The long limbs and the neck involve large sauropods to reach maybe 13 meters into the treetops. In big sauropods, the limbs become tree trunk-like with minimal ankle bones and toes. Very large size comes with weight reduction strategies like extensive use of these pneumatic bones full of air sacs in the neck and vertebrae. Other features could not be minimized so easily. For instance, calculations suggest that a full-grown Brachiosaurus would need a heart that weighs perhaps 400 kilograms, that's like 900 pounds, able to pump blood up the long neck into the head. Now, the theropods also had their giants, such as 12 to 13 meter long animals that reached about 7 tons, namely not quite the weight of a big elephant. They also went the other way on the size spectrum, with 1 meter, say 5 kilogram animals and even smaller birds. The theropods continued the bipedal primitive state of the first Saurischans, with a stance like that of a chicken, but balanced by the long ligament-supported tail. Most are predatory with either ripping teeth or a bill, but the group develops more diverse diets amongst some of the small representatives. For example, beaks also work well for generalized carnivory. My chickens, for example, eat snakes, mice, and amphibians if given the chance. Full herbivory is also present in some clades, such as ostrich and turkey-like oviraptors. Their teeth are consistent with animals that did not process food in the mouth very much, but instead used a gizzard for pre-digestion. Pack hunting has, of course, been hypothesized in velociraptors, as we've seen in the movies, but notably this is not present in birds that tend to be solitary hunters, and that raises doubts about the pack hunting idea. Most of the theropods were feathered from derived tyrannosaurids onward to the various groups of bird-like dinosaurs. The appearance of feathers in large theropods suggests that feathers did not evolve for flight, but instead initially served functions like insulation, brooding, or sexual display. Finally, it's notable that the dinosaur fossil record is remarkably poor, despite more than a century of collecting. As of the 1990s, for instance, we had only 7 moderately complete fossils of Stegosaurus, and tyrannosaur remains are similarly incomplete and rare. One measure is that many fossils are still named, like Stan the tyrannosaur in our collection, rather than just having catalog numbers. Other dinosaur groups such as ceratopsians and duckbills are known from hundreds of fossils, probably owing to this herding ecology of these groups. Even there, most fossils are vertebrae, limb bones, and pelvic bones, since these tend to be heavily mineralized. Meanwhile, skulls, feet, and tail bones tend to be fairly rare. These limitations on fossil materials suggest that we still have a very incomplete idea of dinosaur diversity and morphology. Consequently, we're probably on firmer ground with interpretations of dinosaur paleoecology and taphonomic work than we are with phylogeny and population statistics.